Warahmatullahi wabarakatuh dan salam sejahtera saya ucapkan kepada semua participants dan pengunjung untuk program kita pada hari ini. Sebelum kita memulakan majlis kita dengan rasminya, saya rasa eloklah kita mulakan dengan bacaan Ummul Quran Al-Fatihah dahulu. Amin amin ya rabbal alamin. Pertamanya on behalf of Bitkom, saya rasa belum tambat lagi kot. Kami ingin mengucapkan selamat Hari Raya kepada semua yang hadir pada hari ini, dan kami pada hari ini juga amat berbesar hati kerana kita dapat menerima tiga penceramah yang boleh membantu kita untuk menyampaikan sesi perkongsian ilmu untuk satu model ataupun tajuk program Build Your Own Brand yang lebih akan memberikan tumpuan kepada modul pertama berkenaan dengan prototype and design. Jadi program ini merupakan anjuran daripada kami Bitkom. Sebagaimana yang saya rasa most of you dah tahu, Bitkom adalah sebuah entiti yang mengenengahkan produk-produk yang dihasilkan oleh UiTM. Jadi di Bitkom, program-program pengkomersialan dijalankan untuk membantu para penyelidik mengenengahkan produk-produk hasil inovasi dan penyelidikan ke pasaran terbuka di luar sana, ya. Jadi pencapaian cemerlang penyelidik UiTM dalam pertandingan-pertandingan inovasi telah membuktikan keupayaan penyelidik UiTM untuk menghasilkan produk-produk inovasi yang berkualiti dan mempunyai nilai tambah yang kita boleh ketengahkan kepada pasaran. Jadi sehingga tahun 2021, UiTM telah berjaya memenangi pelbagai tingkat serta anugerah khas antarabangsa di dalam pertandingan inovasi, sama ada dari peringkat nasional dan juga antarabangsa. Walau bagaimanapun hanya 20, kalau kita translate itu kepada peratus, kurang daripada 1% sebenarnya, teknologi produk berjaya dilistinkan kepada industri, di mana 6 daripadanya dilistinkan melalui syarikat pemula dan terbitan UiTM. Jadi kita nampak dah ada satu gap di sini. Kita cuba untuk merapatkan gap tersebut dengan menyampaikan lagi ilmu yang berkaitan kepada, terutamanya kepada penyelidik UiTM dengan bertitik tolak daripada program kita pada hari ini. Jadi objektif kita secara keseluruhannya, kita ingin mendedahkan kepada peserta berkaitan penambahbaikan produk yang sedia ada untuk mendapat perhatian ramai pihak. Justru kita boleh mengangkat produk UiTM ke peringkat nasional dan antarabangsa. Jadi untuk membantu kita mencapai objektif program kita pada hari ini, alhamdulillah kita telah berjaya menerima jemputan 3 orang penceramah bersetuju untuk membantu kita dalam sesi perkongsian ilmu. Kita ada yang pertama, speaker pertama adalah Profesor Media Teknologis Dr. Ahmad Rafizan Muhammad Daud. Yang kedua kita ada Encik Rahman Amin, dan yang ketiga kita juga mempunyai Encik Abdul Hafiz Shah. Alright. Jadi sebelum kita memulakan sesi perkongsian ilmu ini secara rasminya, kita harap kita boleh jalankan program ini secara casual sahaja, ya, sebab kita pun dah nak masuk hari Sabtu dan Ahad, kita nak bercuti, so perhaps we can run this program casually. Dan caranya saya akan menjemput speaker pertama untuk menyampaikan ceramah beliau dan diikuti dengan 5 ke 10 minit Q&A session. Kemudian kita beralih kepada penceramah yang kedua. Kemudian kita beralih kepada penceramah ketiga dan kita akan conclude. Baiklah. Jadi kita mulakan dengan sesi pertama. Speaker yang pertama kita ini adalah Profesor Media Teknologis Dr. Ahmad Rafizan Muhammad Daud. Beliau merupakan seorang pensyarah kanan, ya, di Faculty of Engineering UiTM Shah Alam dan merupakan Head of Industrial Research Laboratory UITM Gaya Plus Berhad at the School of Chemical Engineering UITM Shah Alam. Kemudian Dr. Ahmad Rafizan bekerja sebagai R&D Technical Executive at Penn Century Rubber Sdn Berhad sebelum menyertai the Q18 di SNC Industrial Laminates Sdn Berhad in 2000. Kemudian beliau juga pernah bekerja sebagai seorang production manager at Pacific Activated Carbon Sdn Berhad sehingga tahun 2003. Beliau juga telah berjaya menamatkan PhD di dalam area Chemical Engineering dari Imperial College London, United Kingdom. Jadi pada tahun 2000, between tahun 2000 ke 2007, beliau juga merupakan seorang technical committee members untuk Biomass Refinery Industrial Complex Project hosted by the Office of Science Advisor to the Prime Minister's Department. So bukan calang-calang speaker kita pada hari ini untuk membantu kita bercakap dengan tajuk yang diberikan kepada beliau, Getting Your Prototype Ready. Alright, kalau Dr. Rafizan dah ready, Dr. Rafizan boleh mulakan.
Terima kasih Saudara Helmi. Assalamualaikum dan selamat pagi semua, fellow presenters dan juga participants. First of all, terima kasihlah kepada pihak BICOM kerana menjemput. Alhamdulillah, insyaAllah hari ini kita cuba share santai-santai saja, Encik Am. So kita buat secara santai. I'll try to share whatever that I have picked up over the last 20 years dalam buat benda-benda macam ni lah. Ya. Now let me share my screen. Boleh nampak ke?
Yes,
Boleh.
boleh.
Boleh ya. And my voice is clear?
Yes.
Okay.
Yes, clear.
Alright. So hopefully dalam masa about 30-40 minutes kita boleh tengok sedikit tentang tajuk hari ini, isu yang kita nak bincangkan under module prototype and design ini. So pihak BICOM telah memberikan tajuk Getting Your Prototype Ready pada saya, so saya rasa this is okay, sesuai dengan apa yang saya dah buat. Again, saya daripada School of Chemical Engineering. At the moment, Head of Industrial Laboratory. Our laboratory is Circular Plus, and this Industrial Research Laboratory adalah a program under BICOM yang dinamakan sebagai Micro Industry Hub. So basically, kita bekerjasama dengan industri. They contribute some funds for us to set up the lab, and from there we do the R&D that is of interest kepada kedua-dua pihak. Okay, today a little bit on background and what is Circular Plus, a few minutes on that. Lepas tu kita, walaupun tajuk is Getting Prototype Ready, tetapi we have to look at the broader spectrum so that we know dekat mana sebenarnya prototype itu dalam proses penghasilan suatu produk. Products of invention innovation, kita akan touch a little bit on that. Seterusnya we look at product design, the basic concept of product design. Sebelum kita bincang tentang prototyping dan juga testing. So that will be the structure of my sharing session for today. Okay. Now, a bit of my background. I have to admit that saya tak ada a formal education on product design. My background is chemical and process engineering. Graduated from UKM in 1999. Then I joined Penn Century Rubber. That is my first employment. And at that company, I work on nitrile glove project. So in 1999. Sekarang ni kalau we talk about glove, semua orang akan dengar ataupun tahu tentang Top Glove, Supermax. They are world's largest glove manufacturer. So in those days, they are not as big as now. Yeah? And Pen Century is one of the company yang agak ke depan lah masa tu, yeah? Di Pasir Gudang. And then what I showed here is things that I wanted to invoke ataupun relate later on dalam my talk, because saya lebih kepada, saya rasa lah saya punya experience ini lebih street smart daripada book smart. Ya. I pick up this knowledge through my engagement and experiences in my employment. The activated carbon, passive carbon, we work on pump shell activated carbon product. And then from there onwards, saya adalah sedikit pengalaman melihat kepada teknologi and plant assessment before I went for my PhD and graduated from Imperial College London 2012. Di situ saya letakkan Dragon's Den kerana masa tu saya exposed dengan series. This is one series that I love very much, di mana budding entrepreneurs will go and then pitch their products, and from there you can see many aspects, features, issues yang berkaitan dengan product development ini. Seterusnya 2014 saya dapat together dengan Prof. Asadullah masa tu, we got a PRGS grant, and within the UITM system from time to time kalau ada PRGS, the university also invited me as one of the panel. And then lately 2018 I work on several projects, pilot plan and demonstration punya processing technology bersama dengan Nuclear Malaysia, as well as beberapa company lah. Yang terakhir ini 2021 dengan IWK kita cuba develop process for them. Gaya Plus Berhad is our collaborator, and then I will talk a lot tentang Gaya Plus lah for today. Okay, sedikit on Industrial Research Laboratory. Again, as I mentioned earlier, it is under Micro Industry Hub program hosted by Bitkom, initiative by Bitkom and also pejabat TNCPI untuk memeriahkan I think ecosystem innovation and invention and product development di dalam university. So basically we bring the industry ke dalam university. So at the moment we have several projects ongoing. Yang paling advanced within the group ialah polymerizine development, biohybrid polymerizine. We are now moving on to 3D printing, KLA based filament. And then later on, we have plans for chemical depolymerization of plastics and structures. Okay, so our members, this is very important. Team members is very important if you want to progress. My fellow researchers dalam Circular Plus, Dr. Azrini Ramli, Dr. Istiqamah, both from School of Chemical Engineering. And we have also Associate Professor Dr. Muhammad Hussein Ismail from Mechanical. And at the bottom are our collaborators from Gaya Plus Berhad and Gaya Green Tech. So they are the supporters for the project because that is of interest to their company. So the focus area at the moment, on the left-hand side, is the work on biohybrid. So we have done HDPE, high density polyethylene and palm styrene mixture or blend, and then we are working now PLA and PS, which is polylactic acid polymer based with palm styrene, and we also have plans for chemical recycling and bioplastic. Because the IRL is for 5 years, yeah? So it's a long-term, medium to long-term project. Okay. So these are the products that we have completed so far. We have at the top here the plastic bottles that we have produced. These are the resins, the resins that we produce from this project. And from the resin, we get the bottles, we get the jerry cans at the bottom here. So we will go back to this product later on. Skip this. That's about it. Circular Plus and a little bit about myself, at least hopefully kita ada understanding about what we are going to talk today. And products of invention and innovation. So products are normally born out of invention or innovation. Yeah. So the difference between the two secara simple, secara mudahnya, invention is something new, something novel, something yang belum ada diadakan. And then innovation lebih kepada we make use of the invention yang ada, and then kita innovate, kita improve, kita masukkan elemen usage, kita combinekan beberapa invention sometimes. So kalau tengokkan requirements itu, knowledge, competence, tetapi on the right hand side requirementnya lebih banyak. Yeah? So if we look at invention and innovation, the products of invention is much easier berbanding dengan products of innovation. Tetapi in terms of commercialability ataupun commercial values, the invention kurang sikit berbanding innovation. Sebab selalunya inventors dia fikirkan idea and they think that this is a good idea. So they documented dalam the idea dalam bentuk patents and legal documents. And kebanyakan patents, maybe there are millions of patents yang do not see the end of the day pun. Yeah, they remain as patents sampai they expire. Patents selalunya 20-25 years and then they will expire. So one typical example of something yang kita I think most of us very familiar is barcode. Yeah, barcode was invented many years ago. Sampai patent dia expired barulah dia digunakan. So whoever the inventor was, they lost on the commercial values of the products, the barcode itself. Ya, sebabnya masa dia di-invent itu, the ecosystem does not support the barcode to be used secara meluas. And then kalau kita tengok iPhone, for example, or tablets, so these are all products of innovation di mana sebelum kita ada Nokia, tetapi iPhone comes out with a better user experience, user interface, and so that's where the innovation kicks in, and then it gained traction and being accepted by majority of users. So now they are world leaders in that particular aspect. So both for our discussion today, doesn't matter sama ada the product comes from invention ataupun the products come from innovation, because we are looking at the back end of the product design process. Yeah? Okay, now when we talk about product, kita tak boleh lari daripada this technology readiness level. Yeah? Kalau dekat MOSTI, this is what they employ. Those yang biasa apply MOSTI grant, they are needed to identify their products. Where are they? Yeah? So secara ringkasnya, the TRL system is adopted from the NASA system, whereby they devise a system to evaluate and determine technology maturity and commercial readiness. They started this, if I'm not mistaken, in the 70s, and then they updated the system in 2012 or something. So now mostly adopted this system, and for all their grants, applicants mesti tahu where they are as far as the technology readiness level is concerned. So if we look at the TRL 1 until 9, from here, basic principles, sehinggalah kepada commercial aspect at the back end here. TRL 1 until 4 is within the lab, and then you end up the lab work at TRL 4, then you move to outside the lab. So this is where the products, whatever products that you have, sama ada food ke ataupun gadget ke, electronic devices, chemical, environmental sciences, services dan sebagainya, it has to be validated in real environment, demonstrated, and then you have here a demonstration of prototype. Yeah. So secara lebih jelas kalau kita tengok dekat sini, again this is the same thing as the previous slide, cumanya that we wanted to look at where does this prototype come in. Yeah. So if you look at here, right in the middle, development. So prototype boleh jadi pada TRL 4, TRL 5 dan TRL 6. Yeah. Because kalau kita tengok tadi TRL 7 ialah demonstration in real environment. So prototype pun ada banyak stages. The initial prototype, the more advanced prototype, you know, because you keep doing the testing, refine, and then prototyping again. So that process is a continuous process. So as far as TRL is concerned, prototype selalunya pada peringkat TRL 4, 5 dan 6 inilah. Ya. Okay. We move on to the next one, which is product design. Product design sebelum kita masuk prototype. So secara ringkasnya, product design ini is basically a process to identify market opportunity. Kita define the problem, develop appropriate solutions, and then we validate the solution with real users. These are the steps ataupun the proses yang selalu terlibat dalam proses product design. So you can get it from textbook, you can get it from many articles, YouTube, Google. So they will be talking about something very similar, but of course the approach ataupun the steps will be slightly different for different field. Contoh kalau dalam pharmaceutical, dalam environmental sciences, food, electronics, so maybe they follow certain protocols. Yeah. But in general, we are talking about identifying problems ataupun the needs and opportunities, or a combination of both ataupun ketiga-tiganya. From there, selalunya kita akan buat define the problems, kita define the opportunity, kita define the needs, market needs, for example. And the next one would be to ideate. So this is where we brainstorm our problem that we identified ataupun the market needs that kita nampak dan juga opportunity yang mungkin terhidang di depan mata kita. So we ideate ataupun kita brainstorm and then come up with the proper solutions to the problem ataupun kepada keperluan yang wujud dan juga peluang yang ada. Okay. And from that solutions, kita mungkin ada banyak solutions, but from that brainstorming, we perhaps narrow down to the most viable. So for example, in our case, when we first talked to Gaya Plus Berhad, they wanted to do bioplastic products. And then we discuss, we brainstorm, and then finally kita kata, if you wanted to do bioplastic, fully biodegradable, it will take not 1 or 2 years, but more than 5 years. So as a result, kita kata the most viable options for you now, because you are a going concern business, not product itu, for their own business. So we come up with the idea of biohybrid, which is blending. That will be the first step before we move to fully biodegradable product. So this is where ideation and also brainstorming for solutions kicks in. Followed by POC or proof of concept. This is done in the lab. So then we validate in the lab before we move to prototyping. So what we are going to talk about mostly later on is about this prototyping. And then the prototype, you need to test it in real environment and validate it. So that testing and validation should be done in both a real environment and user environment before you go to demonstration, scaling, and commercialization to the market. So basically, this the steps here, macam saya kata tadi, depending on your products, not necessarily you go all the steps here, But in general, this is what we often see dalam product development, dalam research and product development process. Okay, so it's not a linear process. That means at POC it fails the concept. You have to go back to the problem, define, and then do it again. So katakanlah kita dah sampai prototyping, and then when we test the prototype it fails. So you have to go back to maybe the POC, or maybe to the idea, or maybe further back, to find where does this issue originated. So it requires continual improvement. Yang ini yang penat ni, continual improvement, because product development is not easy. It takes years and years of testings and hard works to get it perfected, and it can be time and money consuming. So selalunya kita gagal di sinilah, time and money punya factors. Okay, so the design process ini allow us to optimize the product development cost, because kita buat secara systematic, so kita boleh optimizekan our R&D cost. At the same time, it can also speed up commercialization journey, because we do it in a structured, in a guided manner. And finally, if after doing all this, and if you have to fail, please fail fast and fail cheap. Ini yang selalu disebutkan dalam product development, because again, as I mentioned earlier, is a costly journey, in terms of time, energy, and money as well. So please, maknanya those yang kalau interested to develop a product, you have to do it properly so that it won't cost you much if you fail. Now, talking about failure, I have to relate to my experience with Pacific Activated Carbon. So I joined the company in 2000 at the time when a local company took over Pacific Activated Carbon from Itochu Corp. Itochu Corp is a big conglomerate in Japan. So in those years, they wanted to streamline their business. So they wanted to get rid of businesses yang tak menguntungkan pada mereka. And this local company, they took over the production facilities in Pasir Gudang, and one of the key decisions that the management made at that time was to decide to change the product from coconut-based activated carbon to palm AC, palm activated carbon. The changes was made because number one, below Itochu Corp pulls out, they stopped buying. Initially, Itochu Corp ini dia buat facility palm coconut shell activated carbon di Malaysia because they're not that material to be supplied to Japan for their other businesses. So when they streamlined, they said we're not going to buy anymore the coconut activated carbon from PAC ataupun Pacific Activated Carbon. So as a result, the new management said, okay, we have palm AC in Malaysia is abundance. Why not we just, we have 20 years. I mean, PAC has more than 20 years of experience producing activated carbon. So why not we just change from coconut to palm-based activated carbon? And that was done without proof of concept, without validation works, without lab works. They just go to the Rotary Kiln here. We see here, this is a Rotary Kiln. Is about 20 meters long. Diameter is about 1 meter. You can go in and then bongkok dalam tu. So temperature is about 900 degrees Celsius during activation process. Then you get this activated carbon. This is palm kernel shell activated carbon. But the decision backfired badly because product is not as simple as it seems. The characteristic, the behavior, the processing parameters, and then this process, when it started, you cannot stop. because the process of heating the rotary kilns will take days before it is ready to receive the materials. So after a few years of trying, I am part of the process. I'm part of the problem as well, because we weren't able to resolve this in time. I left the company in 2003 to continue with my master's degree dekat Sheffield. And I was told that they were bleeding, they were not able to resolve these product issues. As a result, they don't have enough sales. And in the end, they have to close shop. The Rotary Kiln was sold to a company in Sulawesi. Now that Sulawesi company is producing coconut carbon again in Indonesia. Okay, so this is a very expensive experience if you wanted to go into new products without proper validation or proper testing. So, okay, seterusnya, now I think I have another 10 or 15 minutes. So we move to the next one, which is prototyping. Selepas kita tengok product design tadi, the steps of product design. So we will look at prototyping. Talking about prototyping, kita tak boleh lupa ataupun kita tak boleh lari daripada this guy ya. Semua orang tahu dia, semua orang kenal dia. He's famous for his backless vacuum cleaner. Saya tunjuk gambar dia, bukan saya suka dia, but it took him 15 years and 5,127 prototypes before he has his breakthrough. Dia hampir muflis, dia hampir bankrupt, dia jual segala macam rumah harta dia untuk fund dia punya invention, and finally he made it, and he made it back. Ya. Tapi tak ramai lah orang macam dia. Because not many tu kita sentiasa ingat dia ni ya, because kat rumah kita pun ada dia punya invention. And when I did my PhD 2012, belum ada this. Kalau tengok dekat bangunan ini, dekat bawah sini ada sini Dyson School of Design Engineering. Tetapi in 2019 bila saya pergi buat sabbatical dekat Imperial College for hampir setahun, and I saw this Dyson School of Design Engineering. So sekarang dah ada. He donated some amount of money and they set up this Dyson School of Design Engineering. And according to him, proses design ini memerlukan precise measures, relentless testing and prototyping. Yeah. So mengikut dia lah, impatience is one of the challenges. So now they have, and when I was there, I met several students from this region. I did not meet Malaysian student, but I saw 2 Indonesian students doing work at Dyson School of Design. When I said student, it's postgraduate student, PhD student. No? Okay, another experience, because this is sharing session. Pen Century rubber carbonate, Pen Century rubber, no carbon experience. This is my first job. So this is again about prototyping. Pen Century Rubber in 1999 decided to venture into nitrile gloves production due to concerns of latex supply and rising costs, characteristic and functionalities and demand from the USA market. Okay, so these are the defined problems there. They tengok opportunity, so they kata, the management says, I was at that time appointed as technical executive. So the management called me, said, okay, I want you to look into this together with one other guy, the compounding punya expert, latex compounding experts, and I want you to work on nitrile gloves. Okay, so we sit down, small team, starting with 2 of us, me and the experienced compounding guy. So we work in the lab. We look at the existing latex gloves formulation. Again, at this stage, saya kata tadi, glove is not a big business. It's not as now. Kalau kita tengok top glove, they have hundreds of engineers and they have researchers and everything. In those days, 1999, this business bukanlah suatu yang besar, ya. Tetapi Pen Century Rubber is the subsidiary of one of the richest men in India, Aditya Birla Group. So there are Pen Century Rubber, Pen Century Edible Oils, Pen Century, ada satu dua lagi company di Pasir Gudang sana yang under Aditya Birla Group of India. So this lab work involves formulation and lab scale compounding, and then kita buat lab scale prototyping. Selepas itu kita masuk ke kita validatekan kita punya data di dalam company's production line. I left the company after 1 year because ini saya baru je bekerja masa ni, and later on lepas tu they continue with the nitrile gloves lah. So even until now, nitrile glove is very important, because of the functionalities berbanding dengan latex itu. Dia lebih resistant kepada chemical berbanding gloves, and then untuk puncture, sebab gloves latex ni dia macam skin kita, dia very fit nicely, very nice. So kalau ada puncture pun dia suka untuk kita tengok, berbanding dengan nitrile gloves lah, untuk various applications, lab dan juga medical applications. So this is another experience di mana if you do it properly, spend some time, spend some money, get the right people, the right expertise, then you can get it done properly. Ya, berbanding dengan yang experience di Pacific with the carbon. So the purpose of prototyping, before that, macam mana kita nak buat prototype ni? Okay, you have the idea, you dah buat sedikit testing. Kalau you buat cookies, you dah buat bake dalam rumah dan sebagainya. And then if you wanted to go and prototype your products, what do? So there are a few ways of how we can do that. We can do this in-house, kita buat sendiri DIY. Ataupun yang lebih more complicated products, kita boleh outsource kepada third party yang memang dia ada expertise in certain skills and technology. And the third one, kita boleh partner dengan another party. So macam saya kata tadi, product development is not that kita start dengan this idea and then kita end up kita yang commercialkan products itu, because the whole process requires a lot of efforts, a lot of challenges. So most probably inventors takkan boleh work daripada idea sampai ke commercialization punya stage. Yeah, so partner is very important, strategic partner lah. Okay, going back to the purpose of prototyping, kenapa kita buat prototyping? For IPs and specifications, kita nak refinekan kita punya specification, product specifications. We wanted to look at the functionalities or functions and performance, macam mana dia perform bila kita dah buat dalam bentuk products itu. Kita juga nak tengok dari sudut engineering design, because the design is very important. Kadang daripada idea itu kita rasa dah sesuai, tetapi bila kita dah buat, dan kita nampaklah ada kelemahan-kelemahan tertentu. So maybe kalau ada masa ini kita tengok beberapa challenges yang kami pun go through. Okay, going back to Imperial College, I was there, and then kalau kita ada masa sekejap, Dragon's Den is very interesting, orang kata reality TV shows. So kalau yang berminat dengan product innovation, please, the series is still going on until now. Di Australia dia ada Shark Tank, so again whereby inventors and innovators go onto the stage and present dia produk. Okay, kalau sempat kita tengok sekejap saja, 2 minit saja. I choose this. Okay. So in this video, he invented this, and then if you
Dr. Rafizan,
yeah,
video tu tak keluar.
tak keluar.
Dia tak keluar.
Okay. Oh, okay. Macam mana? Patut dia senyap tadi ya.
Saya ingatkan dia. Saya ingat doktor tunggu dia untuk keluar, tapi dia
tak. Okay. Tak apalah. I think saya tak dapat nak linkkan ni. But anyway, because kita pun masa pun tinggal lagi 5-10 minutes. What is important ialah dalam that video, dia buat wrap strap ni, plastic material. That's why I chose this video. And then dia ada element of DIY. Dia buat the prototype tu sendiri. Kemudian dia test produk itu, dia patentkan produk itu di several countries, and then he go and pitch kepada inventors. Okay, now that was in 2009. Kalau sekarang ini boleh pergi ke mungkin selepas ini kalau ada masa boleh tengok dia punya website wrapstrap.com. They have evolved daripada one simple wrap strap products, polyurethane products. Now they work on sustainable material di mana ada elements reduce, reuse and recycling, and they further develop and improve the products from them. Okay, so that again involves apa yang kita dah tengok sebelum ni, continual improvement of your products, because that is part and parcel of product development. Okay, the last 5 or 10 minutes ini saya akan discuss ataupun bincang sikit ataupun tunjuk share what we have done. So this is our project, and our tagline is every little bit counts, because kita produce resin. So I have with me here, this is our resins, and this is our plastic bottles out of the resins. We have also done here in the forms of hangers, plastic hangers, and spoons and forks, as well as containers. Here we have here, nampak container ni. So these are among the products that we have produced daripada this hijau biohybrids resin. Okay. Helmi, what time should I stop? Tak dengar.
Perhaps dalam lagi 5 minit.
Okay, 5 minit. So if you Google dalam YouTube, kita ada our videos hijau biohybrid polymer resin. So you should be able to see our promotional videos. Secara ringkasnya, we have done this since 2020. Kita buat lab works, kita buat proof of concepts with the fund daripada the company Gaia. At lab scale kita produce the resin, and then kita do all the testing dekat factory, dekat outside. We look at not only the resin properties tetapi the products. Lepas tu kita pun test juga dia punya mechanical strength dan sebagainya. Okay, so basically this is a bio-based plastic packaging product di mana kita guna palm stearin. Is a byproduct from palm oil refinery and fractionation. Kita combinekan dengan HDPE. So the palm stearin is commercially available. Dia tidaklah kata murah, tetapi it is within range kalau kita compare dengan biodegradable products yang lain. Yeah. Methods, process and technology daripada POC itu kita move kepada trial in real environment. Kita gunakan pilot scale extruder di KKTM Melaka untuk producekan the resin because the lab scale was a small quantity, tak cukup untuk kita buat trial. So we work at KKTM di Melaka using their pilot scale. This pilot scale costs around 1.7 million. Sebab tu kita tak ada benda ni, a bit expensive. This is a twin extruder, and then dia orang ada juga blow molding, blow extrusion. So from there kita hasilkan film, plastic film ni kat bawah ni, blown extrusion, blow molding bottles, jerry cans and also the caps. So this is where kita demonstratekan the processability of our product ataupun resin tadi. From there kita also buat testing, material and product testing. Kita hantar ke Hong Kong, ke SGS third party laboratories untuk test heavy metal migration test. So the product passed that. And also we spend quite a lot of money to go to OK bio-based certification by TUV Austria. This is for Europe market. So the product received 2-star certification. 2-star means the product contains 40 to 60% renewable material. Kalau 3-star, 60 to 80%. Kalau 4-star is above 80%. Below then 40% is single star products. Okay, so this star rating adalah untuk clients ataupun customers di Europe market because they look at this rating, then they know the products punya content of renewable ataupun biodegradable content. Kita juga dah buat patent, kita file patent ini pada tahun 2020 dan the company has trademark hijau for our resin. So this is had been trademark. Yeah. The Gaia has since orang kata mewar-warkan the products to their clients and they claim that this is the world's first palm stearin biohybrid resin. In fact, memang tak ada pun. Kalau kita tengok dalam mana-mana pun kita tak jumpa lah. Okay, so secara ringkasnya our products dalam kalau kita buat botol, it contains palm stearin, it contains mineral calcium carbonate, it contains HDPE. Initially ataupun sebelum ini 100% is HDPE. So now instead of 100% HDPE which is petroleum based, the bottle ataupun the plastic films ini contains only about 30 to 40% petroleum based material. The rest 60%, 70% adalah renewable materials ataupun green materials. So this is marketable. Kita dah compare dengan competitors. One of the Australian company di Malaysia di Teluk Panglima Garang which is Cardia Bioplastic, they also produce similar. So the product ini kita dah hantar ke beberapa Invention punya exhibition. The reason bukannya kita nak goalkan tu, tetapi kita nak dapatkan feedback daripada third party. So kalau kita tak nak shock sendiri, kita tak nak rasa macam okay kita ada good products, good baby, tetapi bila kita bagi dekat orang, so apa pandangan? So alhamdulillah so far we receive a good feedbacks daripada panels and visitors to our product booth. So it further orang kata boost our confidence lah to work on this project. Challenges tadi semua yang elok-elok yang nampak baik saja, tetapi dalam buat prototyping ini satu, kita kena accept failures. Walaupun kita rasa di lab dah berjaya, tapi bila kita buat it fails. So kalau kita tengok kat sini ada beberapa failures. This is for Rotary Kiln, among the first initial study kita. Bila kita buat standard drop test, it fails. It fails. And then bila kita buat film, ada garisan-garisan, ini is not even distribution, is not. Yang last kali ni, kalau 1-2 hari ni heboh dalam dunia Facebook, Ustaz Kazim kata dia kena sihir katak puru. Kita pun ada juga kena sihir katak puru tu. Kalau kita tengok dekat sini tu, rupa dia macam ni. So instead of very nice bottle, kita ada katak puru. Okay. So kita ada challenges ini, but from time to time kita kena keep on trying. We have to go back to formulation, we have to go back to the process, we have to go back to the parameters and try to fix it. Equipment macam tadi, this is one of major issues. Bila kita nak buat, kita tak ada the equipment, and equipment yang kita perlukan is very costly. Time and money, definitely we need funds for this, otherwise it won't work. Because every single stage yang kita buat ini memerlukan dana lah ya. Disagreements ini satu perkara yang penting lah. Bila kita work in a group, ada banyak pihak, kita punya investor, kita punya company, so akan ada disagreement. So we have to manage this disagreement. Otherwise, after a while kita pun tak happy, dan kita akan separate. I think those are the major issues yang kita kena look out for bila kita nak buat product development, especially yang melibatkan juga prototyping, because you need cost here. Again, saya kata walaupun kita dah ada products, tapi continual improvement is important. Now we are looking at hydroxylation and compatibilization. So secara chemistry-nya kita ada polyethylene. This is palm styrene. Kita nak gabungkan dia dengan lebih baik ya, supaya dia lebih homogeneous, so kita perlukan compatibilizer. And for us to do that, dalam palm styrene dia tak ada OH ni. So kita kena buat hydroxylation untuk masukkan function OH ke dalam palm styrene so that dia boleh combinekan. So this is what we are doing now. Maknanya lab work itu masih lagi berterusan. Kita keep on refining our product. And another part is the palm styrene itself, kita kena tengok konsep ataupun method of drying dia, because we wanted to change the material to a more cheaper and sustainable material daripada FGV ya, Felda. Okay, last kali testing. Now, because after prototype you kena testing 1 minit saja. Ada dua, satu in-house, sometimes mostly kita tahu sebagai alpha testing, and then dekat outside, which is beta testing. So kalau in-house, kita nak test against standard and regulations for the products and functions dia. Kalau dekat customer side, customer acceptance test, customer rasa macam mana. So kita dah buat ni untuk filem dekat Perak ni, dan ada satu lagi kita buat dekat straw punya manufacturer. This is the real customer, so that kita dapat feedback, then kita boleh go back to our site and then work and refine our product. So I think that's all daripada saya. Helmi, terima kasih banyak kerana bagi space dan ruang dan peluang ini untuk berkongsi dengan partisipan yang ada pagi ini, apa yang kita orang buat di Circular Plus lah. Okay, terima kasih.